Alright, so I thought I might show something. Shouldn't be shocking to anyone. The relationship between the completed square and the quadratic formula are definitely known, and you can look them up. And I've cut out all sorts of steps here. But so say we're given a trinomial, and right, so a x squared plus bx plus c equals 0. Right? Now we know from playing around with this earlier that that is the same as ax squared minus 2arx plus aq equals 0, where r is negative b on 2a and q is c on a, and r on its own is the axis of symmetry and the real component of the given parabola, right? The solutions to the given parabola, it is the real component of that, which is why I named it r. And the quadratic formula in these terms looks like this. X is r plus or minus I times the square root of q minus r squared. Okay? So the way that I have this written, it is slightly different than you normally see it, but there's fewer parts, except that like there's this extra part, right, where I get I times the square root of it, but that ends up giving this a nicer structure. When we look at the completed square, it comes back in the same exact way, so that kind of indicates that there's something more fundamental to this way of looking at it than the classical way of looking at it. The reason that it's looked at the classical way in the classical way is that I hadn't been figured out yet when the quadratic was first established. So it really didn't make sense for anyone to look at it this way at that time, and then it became cemented in the culture. So that's pretty much what happened there, I'm pretty sure. Naively, the completed square looks like this. So we get a times the square of x plus b on 2a. So a is in the denominator of that. I didn't put parentheses on there because that would make it more cluttered. And then that minus b squared on 4a plus c. That all equals 0. Okay, so if we factor out an a from everything over here, right? So this ends up being so that we can get this a factor onto everything. We end up with a times c on a. That gives us a times q, and then we can factor an a out and put that inside there. We get a times b squared on 4a squared, and now we get r squared, but we want a negative of that, so we get q minus r squared as a term here, which notice is also in the quadratic formula, right? And we factor out an a for everything, and then over here we get an r squared, well, x minus r squared, right? So if we're taking the square roots of everything, it makes sense that this goes away, this square on the r, and this, we get a square root of it. So we end up with something that it looks really similar to the quadratic formula. So now you have a way of looking at a completed square and the quadratic formula where they're nearly identical to each other. So you really only have to learn one thing at this point, instead of these two completely different looking things. Generally, in my view, that's a better way to learn things, because learning one thing is easier than learning two things.